This is a screencast for Unit 2.5, Natural Disruptions to Ecosystems. So we've talked about ecosystems, limiting factors, such as temperature and light. And natural disturbances can change ecosystems, even sometimes just temporarily, sometimes permanently, depending on what kind of disturbance it is. Now, these are going to be separate from human-caused or anthropogenic disturbances. So right now we're just talking about things that are occurring naturally. So an important part of any ecosystem is its resistance to change, right? Ability to remain unchanged when being subjected to a disturbance. So we can see here in the background, forest fire is a natural disturbance. That is one possibility. And how the ecosystem responds to that fire is its resistance to change. The resilience of an ecosystem is its ability and rate of recovery after a disturbance to return to its pre-disturbed state. So a forest fire may disturb an ecosystem, but it may be fairly resilient. Same thing with hurricanes or volcanoes, blizzards. How much it is able to not change is its resistance, and after it has been changed, its ability to recover from that is its resilience. So here's a chart that kind of shows the difference between resistant and resilient. So let's say on this graph, we have time on the horizontal axis, and then how well that ecosystem is functioning on the vertical axis. So the blue ecosystem is a resistant ecosystem. So it suffers one disturbance and continues to function, but maybe it suffers another greater disturbance at a future time, and that causes its function to drop significantly. In this case, it's able to survive the first disturbance without any change, but then the disturbance is big enough, causes it to reduce its function. Whereas the red ecosystem may be more resilient, so it is disturbed, its function declines significantly to the first disturbance, but then returns to its original level of functioning, so it's very resilient. And even that second disturbance, which is really bad for the blue ecosystem, its function goes way down. The red ecosystem's function declines temporarily, but then returns to its original level of functioning, so it is more resilient. There's a hypothesis that shows that some ecosystems require a certain level of disturbance. So again, if you look at this graph, consider on the vertical axis, it shows the diversity present within an ecosystem. And on the horizontal axis, it shows how infrequent or frequent those disturbances are. So an ecosystem that has infrequent disturbances and a low level of diversity may not be functioning as well, whereas something with a high level of diversity can manage with more frequent disturbances. So we see this most commonly with things like forest fires or wildfires, where certain plants only respond to, like they only distribute their seeds, or their pine cones only open up in certain temperatures that are only present during a fire, like where the temperatures get really high. Also, sometimes, in a forest where there are lots of trees, trees die and they fall to the ground and they're decomposed, and the decomposers are all done. They've taken as much of that tree as they can, but the tree is preventing, other plants from growing in its place because it's there on the ground. Forest fire is good for clearing out some of those dead trees, and then there are nutrients left for other plants to grow. So there are some ecosystems where a certain amount of disturbance is good, and like I said, you can see it sometimes with forest fires. Consider another example, intertidal zones, which suffer a disturbance daily, twice daily. Um, or, there's a high level of water and then a low level of water. And there are some organisms that survive better in the air or survive better in the water. But the disturbance is important because the tide coming in may bring nutrients, and then the tide going out allows those organisms to get oxygen. So modern day change that we're going to talk about more in the future and kind of laced in throughout all these different units is what we call anthropogenic change, which is change created by humans. And so what is different about the anthropogenic change, different from previous types of natural change? Really, the issue is frequency, right? Humans cause disturbances a lot more frequently than most natural natural disturbances to ecosystems, right? So volcanoes don't happen all that often, right? They don't erupt very often. Hurricanes, you might have a hurricane come through an area like once every few years. There are lots of hurricanes, but they don't always strike the same place. But when humans disturb things, they're usually disturbing them all the time, like all the time, frequently, maybe every season, so at least once a year, always in the same place. The other thing that makes anthropogenic change different is its intensity, right? So humans are usually very thorough in their disturbance of an ecosystem, right? If you have ranchers trying to grow cattle in Argentina or Brazil, and they cut down tropical rainforest, right? They cut down everything. Everything gets removed. All the plants, all the habitat, all the animals, all gone. And so the intensity is very high. And even if they were to not use that land for grazing, it would be almost impossible for the land to come back as a tropical rainforest, just because the humans had cleared away every single thing. So certain natural disruptions to ecosystems happen, but most ecosystems have either resistance or resilience to those changes. But anthropogenic causes usually result in permanent changes to ecosystems. All right, so that is Unit 2.5. Please let me know if you have any questions. Any questions?